Hey there, creative coders! This is Benjamin D. Whiting, and welcome back to the Super Collider segment of Null-state's interactive digital art tutorial series. Last week we discussed conditional statements in SCLong. This week we'll talk about how to approach conditional-like instructions in server-side programming. Let's get started. Since we'll be working with Scsynth this week, let's begin by booting the server. So last week I stated quite confidently that conditionals are completely within the purview of client-side programming. Some of you following along might have noticed that, when typing if followed by parentheses in the IDE, an entry labeled if parentheses UGen is found in the autocomplete drop-down box. Looking up UGen in the documentation confirms an entry for a convenience method .if. So was I wrong? Can one use conditional statements, at least an if-then statement, in server-side programming? To answer this, let's write a simple sound-generating function that will output one signal when a UGen returns true, and another when it returns false. Okay, so which UGens return true and false? The answer? None of them do. This is what I had meant when I said conditionals are used in SCLong, not Scsynth. Conditional statements rely on some condition returning a Boolean, true if the condition is satisfied and false if not, and no audio unit generator is capable of doing this. UGens return states of waveforms as floats. Depending on the UGen used, the return float could range between 0 and 1, i.e. pulse and impulse, or between -1 and 1, like what is seen in Synosc and LF noise. As no Boolean is returned, conditionals cannot be used in the traditional sense. Knowing this, what is the purpose of UGen.if? How could it possibly work? The .if method of UGen relies on an assumption, one that is quite common in Super Collider server-side programming. 0 represents an off state, or false, and 1 represents an on state, or true. If a signal is multiplied by 1, we are left with precisely the original signal, while multiplying a signal by 0 will eliminate said signal, as it will no longer exhibit any amplitude. Let's now look at UGen.if. Note that I prefer function call notation for .if as it remains consistent with how I form if-then statements on the client side. If the receiver returns a 1, the true UGen is what is output. If a 0 is returned, then the false UGen is what we will hear, or what will be used as an LFO, trigger, or some other purpose. Let's write a function that will return an A major triad comprised of sine tones when a random number generator returns 1, i.e. true, but a B-flat augmented triad if a 0 or false is generated. Let's call our function RNGSine. We need to use the .abs unary operator as LF noise is bipolar, meaning that it normally returns a value between -1 and 1. As you might have guessed, .abs is short for absolute value, rendering any negative float positive. We then round the returned value to the nearest integer, making sure we get either 0 or 1, but not a float. As you can see and hear, whenever our LFO outputs a 1, we hear the A major triad, while a 0 nets us the B-flat augmented. What do you think might happen if we don't round the result? Let's find out! I'll go ahead and swap out LF noise 0 for LF noise 1, the latter being a linearly interpolating low-frequency noise generator. Your ears will thank you for this. Instead of rounding to either 0 or 1, a float in between emits a mixture of both signals. This is because both UGens are actually always active, What determines the signal we hear is the amplitude of the LFO. The formula shown here is used to determine the mix that UGen.if outputs. First, the output of the receiver unit generator is multiplied by the false UGen subtracted from the true UGen. Once this operation is complete, the false UGen is added. This is best illustrated by the following client-side operations: 0.8 for the true UGen and 0.2 for the false UGen. When the receiver UGen outputs 1, this instruction results in 0.8, or the true UGen. Conversely, a 0 in the receiver UGen spot gives us a 0.2, the false UGen. If the receiver UGen outputs a 0.5, then this instruction also returns a 0.5, exactly halfway between 0.8, the true UGen, and 0.2, the false UGen. Something that will prove very handy is that certain comparative binary operators exist as unit generators themselves, meaning that they can be used server-side. As expected, however, they do not return a Boolean, instead returning the integer 1 if deemed true or 0 if false. Let's return to our RNG-sign function and tweak it so that the true UGen plays so long as our LFO returns a value above 0.3. Since we're no longer going to be cross-fading signals, we can revert back to using the non-interpolating LF noise 0 to save on CPU cycles. Binary operator unit generators do not need to compare a fluctuating value to a static one. Two UGens can be compared with each other. In this case, we're going to compare the amplitudes of two LF noise generators. If rnum1 returns a value lower than rnum2, sig1 will be output. Otherwise, we will hear sig2. We can also check for equivalence, though that requires some extra typing. For whatever reason, the dual equals sign notation does not convert to a BinaryOpUGen automatically, so we'll have to construct it ourselves using the long-form notation. Here we'll output sig1 when the mouse cursor is halfway across the screen horizontally. Otherwise, sig2 will be played. It goes without saying that one can construct the other binary operator UGens using this syntax as well, but doing so serves no real purpose. Also, we need to round the mouse x value, otherwise SuperCollider will output sig1 if, and only if, mousex.kr is outputting precisely 0.5. As we're not working with Booleans, there is no need to nest if-then statements or use a case statement to allow for the selection of more than one UGen from a list. In fact, such actions are technically impossible server-side. One can instead make use of one of the following classes: Select or SelectX. One should use the former when not desiring a mixture of UGens and working with control rate signals. The latter allows for mixing of signals and is what must be used for audio rate UGens. Let's build upon our synth using SelectX and take advantage of the fact that we can now choose between more than two UGens. We'll start by adding a new chord to our arsenal, a B diminished triad. Next, we'll restore an interpolating low-frequency noise generator, but use it to add a bit of a vibrato shimmer to the sonic output. Let's now return to using the mouse to choose between the three audio signals. We need to make sure that the mouse is mapped between 0 and 2, as 0 will return the first signal, 1 will center on the second, and 2 the third. We'll place all three signals into an array. Finally, we'll have the function return the output of the SelectX UGen, where the mouse will choose the signal or mixture of signals from the array. So what if we don't want any noticeable crossfading between UGens? Could we use select? We could if we were choosing between control rate UGens, but with audio rate signals, switching between them will result in noticeable artifacts like pops. Because select exclusively uses integers, the same smoothing mechanism applied to UGen.if is not implemented in select, making it unsuitable for audible waveforms. Thankfully, SelectX uses floats, so by rounding to the nearest integer and wrapping it in a 0.1 millisecond lag UGen, most easily accomplished by the .lag convenience method, we get the ability to switch between more than two signals while retaining the smooth transitions offered by UGen.if. Just as Booleans are not understood by Scsynth, logical operators are incompatible with the server. Server-side programming does not allow for the use of logical AND, OR XOR. There is, nevertheless, good news on this front. Just like the .if convenience method of UGen employs a mathematical formula to determine so-called true and false states, there exist arithmetic workarounds for each of these operators. Logical AND is managed by multiplication. If two control rate signals are multiplied together with an audio signal, they both must be non-zero, ideally 1 or true, in order for the audio to be heard. A 0 registered by either of them will result in the entire instruction returning a 0 value. Take, for example, the following code. We are multiplying mousex.kr greater than 0.5 along with mousey.kr less than 0.5, and finally with brownnoise.ar with an amplitude of 0.1. If neither the mouse cursor is more than halfway to the right of the screen, nor below the vertical halfway point, the brown noise generator will not sound. Even if one of these conditions were satisfied, the unsatisfied condition will return 0, thus causing the entire operation to equal 0 and resulting in no audio output. Logical OR, on the other hand, can be achieved by addition followed by another comparison. When we add both of the mouse X and mouse Y comparison operations together, the satisfying of 1 will result in a value of 1 being multiplied by the brown noise generator, thus leading to an audio signal. If both conditions are met, we face an awkward situation where a value of 2 is multiplied by the audio signal, resulting in 200% of the desired amplitude. This can be mitigated by enclosing both comparisons in parentheses and testing to see if they're greater than 0. Even if both are, what is returned is a 1, thus effectively ensuring an appropriate amplitude. Exclusive OR, or logical XOR, is determined by adding both conditions together, and then checking for equivalence with the number 1. If only one condition is true, 1 is returned as the multiplicand for the brown noise generator. If both are true or neither is true, then 0 is returned, as neither 2 nor 0 respectively is equal to 1, and the audio signal is not heard. There you have it, folks. This episode is drawing to a close, and with it the third segment in our client versus server-side programming tetralogy. The next episode, our 10th in this series, will bridge both sides together utilizing the very mechanism that will allow us to interface SuperCollider with other programming languages and applications, like max jitter and processing. If you have any questions about the material covered in this episode, please don't hesitate to ask in the comments below. In the meantime, please don't forget to hit that like button and subscribe to this channel to show your support for more interactive digital music and art content from us at Null-state. Also, make sure to check out our Facebook page and webpage to stay up to date on all of our upcoming events, workshops, and concerts. The link is in the description below. See you next time!